Okay, so last one. I feel like you guys are getting this stuff. So we got a picture here. A construction worker pulls a 5-meter plank up the side of a building at a rate of 0.15 meters per second, as seen in the picture, by means of a rope tied to one end of the plank. How fast is the end of the plank sliding along the ground when it is 2.5 meters from the wall? How fast is the angle between the ground and the plank increasing at this time? Okay, so let's do the first question first. So what do we need to probably add to our picture here? What do you think?
It's changing.
Okay, good. Yeah, so let's call this distance right here, let's call that x. Anything else?
Well, the end of the plank is 2.5 meters from the wall. That's the distance.
So that's a frame value, isn't it? Right, so what's a frame value for what? X, okay. So we know our frame value list, we know x equals 2.5. What else do we know? What do you think?
Don't we have a right triangle?
We do, yeah. We have a right triangle, you're right. There's a right triangle. What do you think? So the left edge of that plank is sliding up the, whatever that is, the scaffolding, I guess, right? At a rate of what? Okay, so what is that? Okay, so what, yeah, it's got to be a dot, doesn't it? Because it's a rate. So what else do we need in our picture?
A y.
We need a y, don't we? Because there's another thing changing here. Right, this distance is changing, but so is that distance, right? As the plank gets pulled up the wall, right? Okay, so we need this distance, we'll call y, right? And what do we know then?
Y dot.
Okay, yeah. Positive or negative? Positive, isn't it? It's increasing, right? Y is getting bigger. What are we trying to find in the first part?
X dot.
Yeah, it looks like x dot. Okay. Okay, so what are we going to do here? Ideas?
Parent equation that correlates x and y.
Yeah, what would a parent equation be that relates x and y?
X squared plus y squared equals
Yeah, right. That'd just be Pythagorean theorem, wouldn't it? We want to only use x's and y's. So x squared plus y squared equals 25. Okay, now what? Yeah. Okay, so we can implicitly differentiate. What's that give us? 2x x dot plus equals 0, right? Okay, what else could I do to clean that up? Yeah, right, divide each side by 2. Good. Okay, this is looking better. So we're trying to find x dot. Let's see, is there anything there that we don't have in our list that we would need? Y, yeah. Can we find y? Yeah, we can, right? I mean, because in our frame, looks like this picture, doesn't it? That one instant in time. This is 5, this is 2.5, and that's y. So we should be able to just solve for y at that one snapshot, that one frame in the video, right? What would y be? Yes, square root of 5 squared minus 2.5. So that's 5 halves squared. So what's that going to give us? Square root of, that's 25 fourths. That's 25. 25 is how many fourths? 100 fourths.
Dividing.
Right? Okay, so what's 100 fourths minus 25 fourths? Okay. Let's simplify that radical. What's that give us on top? Square root of 75. Yeah, it's just 25 times 3. Good. So what's 5 radical 3? Yeah. So we get 5 radical 3 over 2. Okay, so that's y. And really, oh, never mind. Yeah, we needed that, didn't we? Now we've got everything we need to plug and chug, and we can find x dot, right? Okay. So what is, if I solve for x dot, what is x dot in terms of other stuff? Oh no, this thing's going to crash. I got to save this. Hang on. Did it do it? Okay, yeah, maybe it did. Oh boy. Oops. All right, so where were we here? So we were saying so if I solve for x dot, what do I get on the other side? Negative y dot divided by x. Okay, and we have all that stuff, right? So x dot equals negative y, which is 5 radical 3 over 2, times y dot, which is 0.15, divided by x, which is 2.5. Right? That all good? And so they want this, how? They want this as a decimal. How do they want? Doesn't say. Let's just say we're going to get this as a decimal rounded to 2 places or something. So somebody plug that in. What do we get? We could just cancel all this stuff, couldn't we? Right, so we just get negative square root of 3 times 0.15. Okay, and what should my units be for that?
Meters per second.
Yeah, because we're measuring length in meters, time in seconds, right? So that ought to be meters per second. Good? Okay, how about part 2? For part 2, what does that do to our picture? how fast is the angle between the ground and the plank changing? So now what do we need?
Theta.
We need a theta, don't we? Right. Okay, so we need a theta. So there's our theta. And now for part 2, we know what x dot is. It's about 0.2, oh, is x dot, oh, it should be negative too, right? We had that negative sign there. Agreed? And that makes sense. It should be negative, shouldn't it? Because isn't x decreasing? Okay, so we have a value here. Oh, darn it. Negative. Okay, now we're trying to find theta dot. So what should we do for theta dot?
Well, we could do tan theta equals quadrat.
We could. We could do tangent theta. I'm going to claim maybe there's a better one we could do.
Sin theta equals y over x.
What's going on?
Let's take a test and see.
Okay.
So sin theta equals y over x.
Sine we could do too, but you have a better idea?
I'd say cosine.
Yeah, how come? I agree.
That way we're using values that they already gave us, so we know that they're right.
Well, and they're not, we didn't have to do anything rounded, right? Because we kind of gave a rounded answer for y, right? When we solved for y. We didn't write it as an exact answer, but we know that x is, at our frame, x is exactly 2.5 and the plank is exactly 5. Everybody get that? It's a subtle point, but that's probably a better one to use. Use the one with exact values. Okay, so we're going to use, for part 2, we'll use the parent equation cosine theta equals x over 5, right? Okay, makes sense? Okay, so now what?
Multiply both sides by 5.
I mean, I can.
I think that'd be easier to differentiate.
Okay. Okay, now what?
Maybe sin theta.
Okay.
So just get a dot.
Theta dot equals,
X dot. Solving for theta.
okay, so we're solving for theta dot. So what does theta dot equal?
X dot over sin theta.
Negative x dot over, so we know x dot. What are we going to do about the sine theta?
Will you solve for theta with the parent?
Okay, we could, right? We could, because we have our snapshot up here, right? Where we could solve for theta, couldn't we? Right? That's our frame. How would we, what is theta equal to based on that picture?
Arc cosine of 2.5.
Arc cosine, agreed? Right, from this picture we can see that cosine theta equals 2.5 over 5, that's 1/2. So theta is arc cosine of 1/2. That's just a number, right? That's just a calculator number, but that's an exact number. I mean, that is an exact, just like pi is an exact number if we write it as a symbol, right? So one thing we could do here that's a pretty good idea is we could just say theta equals arc cosine of 1/2 and just plug that number in. What's plan B? What else could we do? There is something else we could do too. We solved this whole triangle, didn't we? Right? We had the triangle 2.5, 5, and then y was a little complicated. 5 radical 3 over 2. And this is theta. So how else could we deal with that sine theta?
Arc sine, arc.
Well, we could do arc, we did arc sine, or sorry, arc cosine, right? We know what theta is. It's as a calculator number. But what about as a ratio? We could make this a reference triangle, right? Because this is, we solved for all sides of our triangle at that one frame value. If I know all 3 sides of a right triangle, any of the 6 trig functions can be written as a ratio of sides, right? So we could also say sine theta equals the ratio of opposite over hypotenuse. So it's 5 radical 3 over 2 over 5, which is the same thing as, I could cancel the 5's and I just get square root of 3 over 2. Agreed? Okay. What is that angle too, by the way?
60 degrees.
Yeah. Isn't that 60 degrees? If theta is, if the cosine of theta equals 1/2, that's 60 degrees, right? Or if the sine of theta equals square root of 3 over 2, we actually know the value of theta. That's a convenient. That's one of our unit circle, familiar places on the unit circle, right? We know the coordinates, those coordinates. So either way we do it, we could just turn that into pi over 3 radians, right? Or we could write sine theta as a ratio, or we could use an arc cosine. Doesn't matter. We can use any of those and plug into our answer here to find, right here, to find theta dot. Okay? So if we take this whole thing and we plug this in, what do we get? Theta dot equals negative, what was that, 0.15, I think, right? X dot was negative though, wasn't it? Agreed? So we get negative.
That's Y dot.
Oh, that's Y dot, whoops, okay.
Was X at 2.25?
Oh, X dot was the one that we solved for. Yeah, right, X dot was roughly 0.26. Okay, gotcha. Yeah, we gotta fix that.
Negative.
Well, no, negative, wasn't it? Yeah, negative 0.26, and we'll just use our rounded number, divided by 5 sine of pi thirds, and we know what that is. That's just sine of theta is just square root of 3 over 2, right? So what do we get here then? 0.26 divided by, 5 radical 3 over 2. And we'll just turn that into, what is that if I turn that into a decimal? 0.060. Okay. What would my units be? No. Okay, could it be degrees per second?
No, it'd have to be radians.
Can't be degrees, right? You can't, theta dot can't be, because when have we ever referenced a degree here, right? Remember, degrees are arbitrary, radians are not, okay? So that's got to be radians per second. Okay, make sense? Now we're getting that? Okay? All right, man, we've been through a lot of those examples. So here's what I want to do with this.